Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In last lecture, we have already discussed a case 8. In case 8, the functions are given. So, how many functions are given in case 8 for finding particular integral? So, in a linear differential equation of second order with constant coefficient, in right hand side of this differential equation is a function that is known as a q. Q is the sum function of x. Q equal to say fx. In case 8, we have discussed from starting one by one case. So that is case number 8. In case number 8, the value of q is given in our question exponential function e to the power ax into sin ax, trigonometrical function, or cos ax, trigonometrical function, and x to the power n, that is algebraic function. So there are three functions which are in multiply, and how we can find particular integral. So this topic we want to discuss today. I have already solved one problem on this topic. So now today I want to solve more problem on this topic. Some other problems, that is important problems in this topic. So I want to solve today in this lecture. In this lecture, I want to more problem depend on this topic. Today I want to discuss some problem based on case 8. But I have already discussed in detail about case 8. In case 8, if q is equal to e to the power ax into sin ax into x to the power n, means in q there are three functions, exponential function, trigonometrical function, and algebraic function. All three functions are in multiply in q. In case 8, we have already discussed a special case to solve a linear differential equation of second order with constant coefficient. In standard form, if q is equal to e to the power ax sin ax into x to the power n, in q there are three functions, all are in multiply, all functions are compulsory. First is exponential function e to the power ax in case 8, and second function is sin bx or cos bx. B is number here, where b is an algebraic function x to the power n. Last third function is an algebraic function. First function is exponential function. Second function is trigonometrical function. But in trigonometrical function, there are only two functions, sin ax or sin bx or cos bx, where a and b is constant, may be positive or negative, but n is always positive constant. General differential equation of case 8 is given as follows. Here d2 by dx2, this is second derivative, multiply by one number here. dy dx, this is first derivative, multiply by p1, p1 is number, and here is y is some function, multiply by p2. So there are three terms in this differential equation. In right hand side, this is the function of q. This is q here. But in q, exponential function e to the power ax, sin bx, trigonometrical function, and x to the power n, algebraic function. This is general differential equation of constant coefficient when q is when in Q there are three functions. R functions are in multiply. So one by one function, we find Pi. P1 and P2 are constants and exponential, and here e to the power ax, that is first function. Second function is sin bx or cos bx. Third function is algebraic function x to the power n. So in Q there are three functions. All functions are in multiply. First function is algebraic exponential function. Second function is trigonometrical function. Only sin bx or cos bx occurs in our function Q. And third function is an algebraic function x to the power n. But here Q equal to e to the power ax into sin bx and into x to the power n. This is Q here. Today I want to solve some more problem based on case 8. Some problems I have already solved, but now we want to solve two more problem in this lecture. Now in case 8, we will discuss about a standard differential equation. What is standard differential equation? So that equation which depend on our question, that known as a general or standard differential equation. So our question depend on this differential equation. So this equation 1 is known as a general differential equation of constant coefficient, which is based on our question. Our question is based on this equation 1 and 2, either this or this. Any one equation are there, this or this. So here d2 by dx2 multiply by 1 p1 dy dx plus p2y equal to e to the power ax sin bx x to the power n. Here three functions are in multiply, or maybe this type d2y over dx2 multiply by 1 plus p1 dy dx plus p2y equal to here same function exponential function cos bx x to the power n. All three functions are in multiply. In first equation is sin bx and second equation is cos bx. Either question may be this type or question this type. So there are two type of problem. First problem, there is trigonometrical function sin bx, other function are same. Second problem, there is trigonometrical function of cos bx, other two functions are same. So there are three functions in Q, all functions are in multiply. Then how we can find particular integral on this case if three functions are given in Q in right hand side of the given differential equation. So here a and b may be positive or and negative number, but n is always positive number. In algebraic function means the power of x square, x cube, x4. So power of x always be positive. So problem 2 based on case 8. Here main target is solving some problem on case 8. So here we want to solve this problem 2 based on case 8. This is very important problem for examination purpose. So here solve d2y over dx2 minus 2 dy dx plus y equal to, in right hand side there are three functions. Here q, x, e to the power x and cos x. Here three functions are there, all in multiply dot dot. So this question same depend on same general equation 1 or 2. So here this is in left hand side, we see that in left hand side there all numbers are in multiply. Here one number, here two number, here one number. So constants are in multiply. So this differential equation is known as a linear differential equation with constant coefficient. Solution. How we can find solution of this question? So very slowly and very easily we want to solve here. So here is d2y. Again we take this question here. d2y over dx2 minus 2 dy dx plus y equal to x e to the power x cos x. This is equation 1. This question is given in our question paper. So now we write first solution. Then we write question which is given in our question paper. Completely question right. That is equation 1. I am writing equation 1 this. Now equation 1 can be written as this equation is derivative form. So here d2y over dx2, this is d square y, and dy over dx, this is dy. So in place of this we write this. So this equation can be written as d square minus 2d plus 1 into y equal to this. This is d form. This equation is in d form. This equation can also written f dy. F dy is equal to q, where q is this. This equation 3. Our equation 2 can be written in the form this fd. This is function of fd. This is function of d into y is equal to q. So we can write f dy is equal to q, where q is this. So this is equation 3, where fd is d square minus 2d plus 1. This is equation 4. Okay. Here we have the value of fd, we have the value of q. So now solution of equation 2 in two part. Solution of we will find out the solution of equation number 2 in two part. Because q is given here, first solution is known as a CF complementary function, and second solution is known as a particular integral. So now here first we will find complementary function. To find complementary function, putting q equal to 0. I have discussed in last lectures. If we find a complementary function only, first then putting value of q. Q is in the right hand side of the given differential equation. So q taken equal to 0. When we are taking q equal to 0, then we can find complementary function. So here we take q equal to 0 in equation 2. Then we get d square minus 2d plus 1 into y equal to 0. This is equation 5. In equation 5, we have taken right hand side as a 0. Means putting q equal to 0. Now in 5, putting d equal to m. How we can find here complementary function? So we can find complementary function, then first we find an auxiliary form of 5. How we can find auxiliary form? Auxiliary form means equation which is in m form. So here d equal to putting m and removing y from 5. Then we get an auxiliary form of 5. So we get this. This is known as a auxiliary form of 5. This is an auxiliary form of 5. That is 6. So m square minus 2m plus 1 equal to 0. This is equation 6. So now factorizing equation 6, finding value of m. Factorizing this equation, after factorizing, then we get value of m. So this is m square minus 2m plus 1 equal to 0. This is depend on given formula. This is based on given formula. Formula is a square minus 2ab plus b square. This formula is a minus b ka whole square. This is identity. This is an identity. This is an identity. So we can write according above identity, then we get factorization of 6. This is perfect square. So here this is m minus 1 ka whole square equal to 0. M minus 1 into m minus 1 equal to 0. If m minus 1 equal to 0, then m is 1. And again m minus 1 equal to 0, then m is 1. So from equation 7, we get the value of m is 1, 1. Here we get roots of an auxiliary form 6, m equal to 1 and 1. Roots are equal here. Roots are equal here. Roots are equal here. M equal to 1, 1. M equal to 1 and 1. Roots are equal. If here roots of an auxiliary form are equal, so we apply here formula for equal roots. Which formula apply for equal roots? So this is the formula for complementary function to apply equal roots. When roots are equal, then we apply this formula. So formula is complementary function is equal to c1 plus c2x in bracket e to the power mx. M is roots here. If roots are equal, then we apply this formula. Remember this formula clearly. c1 plus c2x e to the power mx. So here m is 1 here. So c1 plus c2x e to the power x. This is equation 8. This is complete complementary function of given problem 2. Now, here finding second part of the solution of PI. Second part means second solution of given equation 1. That is second part of the solution. That is known as a PI. We use here formula for PI. How we can find PI? PI equal to formula is 1 upon FD into Q. This is basic formula 1. 1 upon FD into Q. So now particular integral equal to 1 upon FD into Q. This is basic formula for finding PI. Now here 1 upon FD. Here type of the function are this exponential function, trigonometrical function and algebraic function. This is general function I am writing here. This is equation 9. I am not writing our question here. This value of Q is general here. So I am discussing what we will do here to solve this equation. So here 1 upon FD into Q, here exponential function only. First we are taking exponential function. In every question when exponential is given, then exponential is taking to left side. This is rule. So exponential taking to the left side of PI in multiply. So e to the power ax is this in multiply. This is out of integral, out of particular integral. So here x multiply with x is a. Multiply is variable with a here, e to the power ax. So putting d equal to d plus a. D convert into d plus a here. When exponential function taking left side to the particular integral, then in our question putting d equal to d plus a. I am telling you last problem. Several times I am discussing this point. So here f d plus a. Remaining two functions are there as it is. One function, exponential function taking left side, and other two functions are same place and putting d equal to d plus a. A is the power of e and multiply with variable x, e to the power ax. So value of now we solve our question. So here putting value of q from 3 equation. In our question putting value of q from 3 and fd from 4. Both value I am putting here. Fd from 4. So what is result here? Pi is equal to here 1 upon Fd and into Q. So 1 upon Fd means d square minus 2d plus 1 into Q. Q is e to the power x and cos x and x to x. So now next 1 upon, this is the perfect square here. D square minus 2D plus 1, this is D minus 1 ka whole square. This is perfect square. So here I am writing D minus 1 ka whole square and e to the power x into cos x, x. So now next pi. Here rule 1, I am telling rule 1 this. We have discussed in case 8, if q is this function, 3 functions in q, then exponential function e to the power x taking it to the left side of pi in numerator and sin bx x to the power n taking right side of pi in numerator and putting d equal to d plus a and denominator in place of d equal to d plus a putting in denominator of particular integral. So I am putting here, this is d minus 1 ka whole square. Now next, same result I am applying here. E to the power x taking left side, then d equal to putting d plus 1 and minus 1 here, d minus 1. D plus 1 here, e to the power x taking left side, putting d plus 1 and minus 1 ka whole square. In last equation, we have right here d minus 1 ka whole square. So exponential function taking left side and putting d equal to d plus a here. D plus a is 1 here. A is 1 here. So putting d equal to d plus 1 into other two functions are same as here x cos x. Other two functions are not changed here. So 1 is cancelled here. So we find here e to the power x 1 upon d square x cos x. This is equation 30. Okay. Here d plus 1, I am writing this correct, this result. So here x cos x, this equation 13, d square. 1 upon d square, I am writing 1 upon d into 1 upon d. X cos x is function. E to the power x 1 upon d means integration. 1 upon d integration with respect to x. Here 1 upon d means integration function x dx. One time integration function. Here is function. Any function is there here. So now what here function is x cos x. So 1 upon d, 1 upon d. Multiply v 1 upon d square. 1 upon d square breaking 1 upon d and 1 upon d. So here 2 time integral this function. This is the method 1. We can integrate x cos x 2 times. Then this is the complete pi. So now pi is equal to here 1 upon d e to the power x 1 upon d and integrating this function. Integrating x cos x and dx. Now dx. So one time here integrate. This is u, this is v. So ub formula apply here. Integration f1 into f2 dx. So here f1 is constant, integration of f2 dx and minus sign, differential of f1 and integration of f2 dx and whole dx. So this formula we apply here. So here e to the power x 1 upon d and here u is x. So x is constant, integration of cos x. Integration of cos x is sin x and minus sign. Differential of x is 1. Integration cos x is sin x. So again integrating this dx. So now here e to the power x 1 upon d e to the power x 1 upon d x sin x in bracket x sin x and integrating of sin x again. Integration of sin x is minus cos x. So here we get answer here plus cos x. And again integrating it dx. 1 upon d here. So 1 upon d means again integrating this function. So we write here e to the power x. Again integrating this x sin x and plus cos x and dx. So here again apply here product rule. So e to the power x e to the power x here. Now integrating x sin x and dx and plus integrating cos x dx. So now here apply UB method, U and B method. E to the power x here. This is x constant. Integration of sin x means minus cos x and minus sin. Differential x is 1 and plus cos x and dx. Again integrating here. So plus here cos x. Integration cos x dx. So now here e to the power x in bracket minus x cos x. Integration of cos x is sin x plus sin x and here plus sin x. So here e to the power x 2 sin x. 2 sin x minus x cos x. So this is answer pi. This is pi. We apply here method 1. We can solve this question by method 1. So we want to solve this question again by method 2. From equation number 13, this is equation number 13. Okay. 13 equation is given there. 13 equation can solve further by 2 method. One method is direct integrating 2 times this given function. This given function direct integrating 2 times. Then we get our answer. Here apply UB method here apply. So U is x, B is cos x. So what is UB method? Here is U into V dx. This is equal to U constant integration of V dx minus sin d over dx of U integration of V dx and whole integration. This formula is applied here. So now here x is U, x is constant, integration of cos x. Integration of cos x is sin x minus sin. Differential of x is 1. Integration of cos x is sin x. Then again integrating. So here e to the power x 1 upon d. Here x sin x. Integration of sin x means minus cos x. So we get here plus cos x. Plus cos x. One time integrate. After integrating one time, we get this solution. X sin x plus cos x. Now, ought is again 1 upon d. 1 upon d means again integrating. So, again integrating e to the power x, integrating this function x sin x plus cos x dx. So, now e to the power x, integrating function x sin x dx plus cos x dx. So, again apply here formula UB method. X is constant, integration of sin x. That is minus cos x. Integration of sin x is minus cos x. Minus sin. Here is minus formula. Sin is minus. X is 1. Integration of sin x is minus cos x. Minus minus plus cos x dx and cos x dx. So now minus x cos x. Integration of cos x is sin x. Integration of cos x is sin x. So here is 2 sin x. Taking first 2 sin x minus x cos x. This is complete pi. Okay, this is method 1. We can integrate direct the function. But now we here solving this question by other method. So apply here method is 2. What is second method? Putting cos x. In our question cos x is there. So putting in place of cos x real part of e to the power ix. Cos x is real part rp of e to the power ix means cos x plus I sin x. Cos x plus I sin x. So this is real part. Real part of this function is cos x. Now from equation 13 we have. So now this question I am solving now next method. Other method we apply here. First method we already solved. Apply here direct integration, 2 time integrating the given function. But now we apply other method. So this question we can solve by 2 methods. So now pi equal to e to the power x 1 upon d square rp of x e to the power ix. Means here in our question is pi is equal to 1 upon d square and x cos x. Okay, this is equation 13. In equation 13, 1 upon d square x cos x. Here is cos x is there. In our 13 equation, x cos x. So cos x is there. So in place of cos x, I am writing Rp of e to the power ix. I have here written it. Here this cos x equal to real part of e to the power ix. So I am writing here cos x. Cos x equal to Rp of e to the power ix and x. So this is equation 14. Now Rp of e to the power, Rp of taking before this integration, Rp of. So pi equal to e to the power x, Rp of 1 upon d square x e to the power ix. So here again we get exponential function. There are two functions, algebraic and exponential. Exponential is imaginary function here. So there are two functions in multiply. What we get again? Exponential function. So exponential function again taking left hand side. Here e to the power ix taking left side of pi. In multiply in numerator, then putting d equal to d plus I. Then we get in our question d equal to d plus I. So e to the power ix taking left side, this one, and putting d equal to d plus I. D square, here is d square, d equal to d plus I, so d plus I ka whole square. Here is only single function is x. Exponential function, this one goes to left side. So this is equation 15. So e to the power x, Rp of e to the power ix, 1 upon. Now, here, minimum power of d, minimum power of d, taking common from denominator. In this denominator, taking minimum power of d. Minimum power of d is here d to the power 0, here d to the power 1. So I is taking common only. So here is square. So I square taking common. Now Ip of e to the power x, Rp of e to the power ix, I square taking common from bracket, I square. So here 1 upon 1 plus d upon I ka square into x. This equation 60. Now pi equal to e to the power x, Rp of e to the power ix. Here I square is minus 1. 1 plus d upon I. This is taking in numerator. This factor writing in numerator. So we get is negative power. Minus 2 power into x. X is function here. So this is equation 16. Expanding by binomial to equation 16. Apply following formula. This is formula for binomial formula. Binomial formula this. Binomial formula. What is binomial formula? 1 plus x to the power n equal to 1 plus n into x plus n minus 1 upon factorial 2x square plus n minus 1 n minus 2x square x cube. This is x cube upon factorial 3 n plus this. So here in our question n is minus 2, x is d upon I. Okay. Both value putting here. Then we get e to the power x, Rp of e to the power ix, 1 upon minus 1. Here 1, first result is 1. Minus nx, n is minus 2. So minus 2 into x d upon I. Plus, here minus 2 minus 2 minus 1. Minus 2 minus 1. Into d square upon I square upon 2. So now, this is minus 3, this is minus 2. So this is plus 6. This is minus 2. And similar we can write here. So next result is here. Exponent e to the power x, Rp of e to the power ix, 1 upon I square, this is minus 1. 1 minus 2 d upon I plus 6 upon 2 d square upon I square minus 24 d cube upon I cube upon 6 and plus this. This is exponential function. Here we see that if b multiply by I in 13, multiply by I in 13, then multiply by x in 13. This x is outer function. If this function taking inside, x function multiply in bracket, then this function is differentiate. Here 3 time differentiate, here 2 time differentiate, here 1 time differentiate, here no differentiate. So here in this bracket, there are derivatives are given and outside is function is x. When this function goes to inside the bracket, then this function differentiate. So here we see that if we multiply by x in 13, this equation, then x will be differentiate. This is equation number 17. So here pi equal to e to the power x, rp of e to the power ix 1 upon I square. Here multiply by this x in bracket. So x 1 ja x here minus 2 dx. D is differentiate, derivative here. So x differentiate 1 time here upon I and 6 upon 2. Here d square, 2 time derivative here. When x multiply to this d square, then this is 2 time differentiate, d square x upon I square. Here is d cube, 3 time differentiate. So x multiply here, then 3 time differentiate x, d cube x upon I cube. So here, we know that the derivatives of x is different derivatives of x. First derivative of x is 1. First derivative of x is 1. Second derivative of x is 0. Third derivative of x is 0. Nth derivative of x is 0. Only single derivative is constant 1. Other all derivatives are 0. So these are value putting here, then we get particular integral e to the power x rp of e to the power ix 1 upon minus 1. This is value of I square. Here I square is minus 1. So we write this value. X minus 2 dx is 1. So 1 upon I. D square x is 0. So this function is 0 here. Now here particular integral e to the power x rp of e to the power ix 1 upon minus 1 x plus here. In last question here minus sign is there. 2 into 1 upon I. Minus 2 upon I. So here is minus 1 into 2 upon I. So here multiply by I in numerator and denominator. So I upon I square. I square again is minus 1. So that is plus 1. So here plus 1. Here is minus 1. So here is minus 1 plus 1 plus 2i. Multiply here by I. So here x plus 2i. Minus minus plus and x plus 2i. So minus sign. This minus sign goes to here. E to the power x rp of e to the power ix x plus 2i. So here minus e to the power x rp of. This is the value of e to the power ix. E to the power ix I am writing value cos x plus I sin x. So I am writing here this value expansion of e to the power ix here. Open this. So this is real and imaginary part. This is real and imaginary part. So now equating real part, because in our question is cos x given. If cos x given, then we equating real part. If sin x given, then we equating imaginary part. So both solutions are come simultaneously here. If in our question given is sin x, then we get direct answer. If cos x, then we get direct answer. So here is in our question is cos x given. So here equating real part. So answer is here minus e to the power x real part. What is real part? Real to real, multiply real to real and imaginary to imaginary. Then we find real. So here is x cos x minus. Here is this I into I square. I square is minus. So minus 2 sin x. Now multiply this minus sign in bracket. Then 2 sin x minus x cos x. So this is pi. This is second method to find the particular integral. First method I have applied here. Then there, what is their answer? Here 2 sin x minus x cos x e to the power x. So answer is same. In both methods, we get same answer. So here we can apply more than one method in our question. Okay. So now complete solution of y complementary function plus particular integral. So y is equal to c1 plus c2x e to the power x plus e to the power x 2 sin x minus x cos x. This is complete solution of our problem. This problem we solved particular integral by two methods. One method, we can direct integrate two times of the given function. Other method, we can taking real or imaginary part of the sin x or cos x. Then we can solve this question. So now here we will discuss case 9. Case 9. What is case 9? So if in case 9, q is x to the power n cos ax or x to the power n sin ax. That is case is very easy with respect to case 8. Because there are three functions in multiply. But here is only two functions are multiplied. Algebraic function and trigonometry function. Algebraic function and trigonometry, either cos ax or sin ax may be there. So here q is x to the power n and cos ax. Like this x cos ax, cos 2x, x square cos 2x. So these type of functions comes here. So now what is pi? Pi is 1 upon fdq. 1 upon fdq. So fd and q is x to the power n and sin ax. So now in this method we want to solve one problem. Problem is there. d2y over dx2. This is second derivative minus 2 dy dx plus y equal to x cos x. Here only two functions are in multiply. In last problem there are three functions are in multiply. So there is lot of changes in this question. This question is very easy with respect to last question. Because in last question there are three functions. In this question there are two functions. So two functions solving very easy problem. So now equation 1 can be written as d square minus 2d plus 1y equal to x cos x. This is q. This is equation 2. Now this equation can be written as f dy equal to q. Where q is this not here. Q equal to x into cos x only. This is equation 3. Where fd equal to what is fd? D square minus 2d plus 1. This is equation 4. Solution of equation 2 in two parts because q is given here. So first solution is complementary function and second solution is pi, particular integral. So now here first we will find complementary function. To find complementary function, put it q equal to 0 in equation 2. Then we get, after putting q equal to 0 in equation number 2, then we get this result equation 5. What is 5 equation? D square minus 2d plus 1y equal to 0. This is D form equation. When we finding complementary function, then we write our question in D form. Now in 5, putting d equal to m and removing y from 5, then we get an auxiliary form of 5. This equation 5, d equal to putting m and y removing, then we get an auxiliary equation of 5. So that is m square minus 2m plus 1 equal to 0. This equation 6. Now factorizing equation 6, finding value of m. After factorizing this equation 6, then we find value of m. This is m square minus 2m and plus 1 equal to 0. So m square minus 1 plus 1 into m plus 1 equal to 0. So m square minus m plus 1 equal to 0. So m is common, m minus 1 common, m minus 1 equal to 0. So m minus 1 and m minus 1. This equal to 0. So here value of m is 1 comma 1. Means roots are equal here. Roots are equal. Now factorizing equation 6, finding value of m here. This is m square minus 2m plus 1 equal to 0. This is depend on given formula. Here this is given an identity. Identity is a square minus 2ab plus b square. This is a minus b ka whole square. We can write according above identity. Then we get factorization of 6. Here we have given factorization. One method is this method. This is one method we can, this is factorizing method. But here we can apply perfect square method. If our equation is a perfect square, then we can apply perfect square method. If not perfect square, then we can factorizing this. So now we apply this identity. So m minus 1 ka whole square equal to 0. M minus 1, m minus 1. This factor repeated twice by multiply equal to 0. So if m minus 1 equal to 0, m is 1. Again if m minus 1 equal to 0, m is 1. Here we get roots of an auxiliary form 6, m equal to 1 and 1. 1 and 1 means equal roots. Roots are equal. Equal roots. Here roots of an auxiliary form are equal. Roots of an auxiliary form are equal. So we apply here formula for equal roots. So this is formula for equal roots. CF is equal to C1 plus C2x e to the power mx. M is number here 1. 1 roots. So writing here m is 1. So CF is C1 plus C2 x e to the power x. This is complementary function. So this equation number 8 is complete complementary function of given problem. Here finding second part of the solution, that is Pi. We use here formula of Pi. What is formula? We have applied in each question, that is basic formula for particular integral, that is Pi equal to 1 upon fd into q. 1 upon fd into q. Here q is cos bx into x to the power n. This is equation number 9. What we are doing here? Here this is cos bx. Cos bx is real part of e to the power I bx. Cos bx is real part. Cos bx is rp of e to the power I bx. Real part of this. So we can write in place of cos bx this function. So I am writing here cos bx is rp of e to the power I bx into x to the power n. So what is next step is? Next step is I to the power I bx. In last line, their exponential function is right hand side to the particular integral. When this exponential function taking left side to the particular integral in multiply left side, in multiply of pi, then putting d plus ib. So I am putting here rp of e to the power I bx 1 upon f d plus ib. Here only algebraic function are there. So this equation 10, we apply this procedure in our question. But now in our question, particular integral 1 upon fd q, 1 upon fd, this is the value of fd, d square minus 2d plus 1. Here I am showing general method. In equation 9, we are showing general method. In general method, what we are doing here? Same process we apply in our question. In our question, here given cos bx, trigonometrical function is given, either sin bx or cos bx. If cos bx is given, then we are writing rp of e to the power I bx. Cos bx means e to the power I bx. So e to the power I bx, rp of e to the power I bx, writing in place of cos bx in our pi. Then e to the power I bx taking left side of pi in multiply in numerator. Then putting d equal to d plus ib. B is constant in our trigonometrical function. So here same process we apply here. Rp of e to the power ibx putting 1 upon fd plus ib. And algebraic function are same there in same place. No change the place of algebraic function. Only exponential function goes to left side of the pi. So now same process we apply in our question. Pi equal to 1 upon fd into q equal to fd. What is fd here? Fd is d square minus 2d plus 1 or into qx cos x. So here cos x is cos x, cos ax, a is 1 here. Cos ax, that is cos x. So a is here 1. So e to the power iax means e to the power ix only. So here I am writing rp of e to the power ix. This is in place of cos x. So x cos x, rp of here, rp of e to the power ix, rp of cos x plus I sin x means cos x. So because e to the power ix is cos x plus I sin x. So now here e to the power ix taking left side. Same process. E to the power ix taking left side and putting d equal to d plus I. T plus I minus 1 ka whole square. In our last step, we have here d minus 1. D minus 1 ka whole square. And d equal to putting here d plus I. When this function goes to left side. Here this function goes to left side, then d equal to putting d plus I in our question. So d plus I minus 1 ka square into x function only, algebraic function there. Rp of e to the power ix. Here lowest power of d is taking common. Lowest power of d taking common. So here I minus 1. This place is d to the power 0. Here is d to the power 1. Here is d to the power 0. So lowest power of d in place I minus 1. So I minus 1 taking common. So I minus 1 taking common means I minus 1 ka square common. So here 1 plus d upon I minus 1 ka square. This is square here. So Rp of e to the power ix 1 upon I minus 1 ka whole square and 1 plus d upon I minus 1 ki power minus 2. This function taking in numerator and x. This equation 15. Expanding by binomial equation 15, apply following formula. This is binomial formula. We apply here 1 plus x to the power n. Here is 1 plus nx plus nn minus 1 upon factorial 2x square. N minus 1 n minus 2 upon factorial 3x cube. And plus so this goes up to infinity. So now here pi equal to rp of e to the power ix 1 upon I minus 1 ka square and here 1 plus minus 2 d upon I minus 1 and minus 2 minus 2 minus 1 upon factorial 2 d square upon I minus 1 ka square and same up to x. This equation 16. Now this algebraic function here x, this function multiply in bracket, then this derivative here, differentiate here 2 times, d square x 2 times differentiate 0, here dx 1 time differentiate, this is 1 and here only x here. So multiply by x in bracket, then we get here x dx upon I minus 1, d square x upon I minus 1 ka square and here out is a whole square. So now this term is 0. D square x is 0. D cube x is 0. Dn x is 0. So all terms are vanished. Only one term is 1. So 1 upon here is square. 1 upon I minus 1 ka whole square. X plus 1 upon I minus 1. Dx is 1. So 1 upon I minus 1 here. And here is minus 2. Minus 2 I minus 1 here. Here is minus 2. Minus 2 here. So now next, here is minus 2. So here I plus 1 is squaring this one, I plus 1. Here is I minus 1 ka square. So I plus 1 ka square this. So here is I plus 1 ka square upon I square minus 1 ka whole square. I square minus 1 ka whole square. Here is x plus minus 2 here. Because here minus 2 into d upon I minus 1. So minus 2 is there. So now minus 2 this one. I plus 1 upon I. So I square minus 1. So I square is minus 1, here is minus 2. So this minus 2 is this here. So minus 2, this minus 2 cancel. Okay. So here is I plus 1. This minus 2 is cancel here. So now here is minus 2. I square minus 1 ka whole square. So minus 2 ka whole square here. This is square. This is also square. So now here Rp of cos x plus I sin x. So this ka square upon here plus 4. Minus 2 ka square is plus 4. And here is in this side is this 2 cancel. So here x plus I plus 1. X plus I plus 1. Here x plus not 2 here. X plus I plus 1. I plus 1. X plus I plus 1. So Rp of this cos x plus I sin x here plus 4. And numerator I plus 1 ka whole square. I plus 1 ka whole square. So here I square plus 1 plus 2i. Expanding here I square plus 1 plus 2i. And into here is not 2 here. X into I plus 1. X into I plus 1. X into x plus I plus 1. Multiply this I plus 1. So x into I plus 1. So now here x plus I plus 1 upon 4. 4 this. So here equating real and imaginary part. So here is I square minus 1. So this one is cancelled. Here is 2i upon 4. And here is x plus I plus 1. Okay. So this is here mistake. So multiply I here. So 1 upon 2 and in bracket here. This is wrong. So here multiply by 1 upon 2. X plus I plus 1. Okay. And multiply by ix and I square. So I square is minus 1. This is only 1 upon 2. This cancel to this. Here is ix only. Okay. So here real part of this. Cos x plus I sin x. Here is ix only. Multiply by this. So this is wrong here. So here pi equal to Rp of cos x plus I sin x and into 1 upon 2 into ix. Okay. So now equating real part. Equating real part. Real part. So here multiply this to this here only. Not this to this. Only imagine real part we are taking here. So I into I is minus sign. Minus 1. So we get here minus xy2 into sin x. This is real part. So this is pi. So complete solution of this y is equal to c1 plus c2x e to the power x and here 1 upon 2 x sin x. This is complete solution. Okay. There is in this question there is some mistake, so this answer is wrong. This total answer is wrong. This is correct answer. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.